before we start the math, all right, I want to let you guys in on something here, all right? So I want to make sure I'm honest and telling you the truth here. You guys always get the best of the best from me, because if I ever make a mistake in 7th period, it's never going to happen again 8th period, and I look like a genius. I may get rattled here today. Okay, I may get rattled. Right after school today, I have to head over to Slingerland's, and I am the mystery reader for my daughter's 3rd grade class. So my nerves are just going crazy right now. Like, I've been in tons of pressure-packed situations in my life, from teaching, coaching, and life in general, but nothing compares to what I'm about to walk into in about another hour. All right, so I might seem a little rattled because I got something else on my mind that I gotta, the day the crayons quit, went through that. I had 5th and 6th period free today. I was at my desk just flipping through the book, making sure I knew all the words and I wasn't going to stutter over everything and embarrass my daughter and embarrass myself. So, all right, hopefully I still bring my A game here. All right, we'll see how it goes. Anybody crayon the day the crayons quit? Duncan? It's like a whole series of books, I think. Okay, never mind. You guys know books? Talking, open it up. Good, they got words on them. Yep, left to right. All right, so let's get through the notes here. Still going to do word problems with you. Still word problems. But now you're going to see 2 new terms. First one, angle of elevation. Angle, so it's going to be in degrees of elevation. That is the following. And also, I despise this day. I do not look forward to this day, because this is where my artistic skills have to be revealed, and they are below average. All right, they are not honors BC. All right, you're going to ask, what class are you teaching? And I have no idea. All right, so let's start this off right. So your angle of elevation, you're always looking up at an object and forming an angle, looking up. All right, so if you're standing on level ground right here, all right, and let's say you're looking up at a tree, all right, or maybe something on fire and there's smoke coming out. Right? Whatever you guys want. It doesn't get any better. I'm sorry, it doesn't. I'll be around judging your diagrams in a couple minutes, though. All right, so we're looking up. So you're at level ground, looking up at an object. But you'll notice I didn't make an angle. All right, I made part of an angle, but where's the other side of that angle? It's you looking up at an object with your horizontal line of sight. This right here, what I've created, that's my angle of elevation right there. All right, that's an angle of elevation. Looking up at an object, but the other side of the angle is if you were looking straight ahead. So looking up with what's straight ahead. So there's elevation. All right, you're on the ground looking up. That's what you have to remember for me. Looking on the ground, looking from the ground, looking up. All right, and the other one is, all right, let's reverse it now. Depression, angle of depression. Now you're on top of something looking down. So let's say you're at the top of a building, looking down at the ground. Now, what are we looking at here on the ground? I know, you tell me. What are we looking at?
A car.
A car on the ground?
Draw frog.
We got 4 legs? Frog 4? I have no idea. And they got a little head, right? They have those little heads. Can I fill it in green? There you go. There we go. Fill it in green. And it's got, you probably got some spots on there. Right? There you go. Okay. So there you go. All right. So you are on top of something, looking down. Now here is what I need to drive home. Everyone's always going to assume that, that angle I just made is depression. No, it's formed the same way elevation is, with you looking down and your horizontal line of sight. This angle is your angle of depression. So that's going to cause a problem when we do our first word problem, because everyone see the right triangle here? Where's the angle of depression? Outside, though. It's outside, isn't it? So how can I use it in sine, cosine, tangent if it's outside the triangle? So we're going to have to talk about how do I solve that problem? How do I get that angle somewhere in this triangle? Okay. But again, depression, looking down with your horizontal line of sight. All right, we ready? All right, first one up. Let's talk about Scott. Oh, look at this one here. Scott, his eyes are 1.5 meters above the ground. All right, let's throw it on the diagram. His eye level, 1.5 meters above the ground. Done. He is 30 meters from the tree. Do we know where to put the 30, huh? 30 meters from the tree? We know where that goes? Okay, we can put 30 meters here, right, from the tree. All right, now here's this term again. Angle of elevation. So he's looking up at the bird. So his eyes looking up at the bird. And now how do I finish this 36-degree angle? Along with his horizontal line of sight. See the angle we just created there? That's your angle of elevation. Looking up to the bird with the horizontal line of sight, 36 degrees. And then finally, how far above is that? The ground is that bird. So what do we got? We got bird to ground, right? Bird to ground. What's that distance? All right, do you see a right triangle I can make at least so I can get rolling here? Okay, we draw the vertical leg in. Boom. There's my right triangle. Oh boy, I need help though because in sine, cosine, tangent, I at least need to know one side length. And I don't have any labeled on that triangle. Any sides there? Petro, what's good back there?
The bottom side, which is adjacent to the angle 36, is 30 meters.
Yeah, if he's 30 meters from the good job. If he's 30 meters from the tree, that's got to be 30 meters. Which side are we trying to find? The leg or the hypotenuse? Leg or hypotenuse do I want here? If it's going to help. Which one? Leg. But all right, when I find when I find the leg, is that going to be my distance from bird to ground? No. Okay, we'll talk at the end how to fix that then. All right, so how do I find that leg? Let me go around the room again. 26 is the 30. What's the 30? Opposite, adjacent, or hypotenuse to the 36? Adjacent. How about the x? Opposite. Ooh, first time, I think. This is the first time we've used this. Which ratio am I going to use? 24. Tangent. Good work. Tangent of 36 equals, put it in the right order for me. What's the ratio going to be? Ooh, 2.
X over 30.
X over 30. Opposite over adjacent. We make a proportion out of it. This is day 3 now. I think I'll stop saying that. Cross multiply. I get x equals, I'm going to ask you one more time. Is this going to be my distance from the bird to the ground?
No.
And anybody know why I asked that for a second time? Brody?
You don't want us rounded it?
I am not rounding that number you're getting in your calculator. Okay, I'm keeping the full calculator display since it's not our final answer. $21.79627584. Looks good. All right, then how do I get that actual distance if that's not it? Oh, 10.
Subtract the 1.5 meters. Add the 1.5 meters.
Right, if I subtract, that's going to get smaller. Right, so add it. Zach, you all right?
Yeah.
Okay. You're more rattled than I am. And now can somebody round to the nearest tenth for me, please? Nearest tenth. 22, when you're ready.
23.3.
There you go. And you guys know how I feel. You want to put units on, fine. If not, fine too. So 23.3 meters. Angle of elevation. We all right looking up before we go depression? All right, what do you got for me for depression? There's our boy, Big Al. Aerial view. Ooh, watching his friend approach the building. I wish I had friends. Going through your mind right now. I'll get back to the 40 in a second. Rooftop, 16 meters. Let's throw it on there. Rooftop, 16 meters from the ground. Big Al's eye level, 1.8 from the rooftop. All right, let's get back to that 40 now. Angle of depression. So Big Al looking down on his friend, but that's not the angle of depression. Remember, that 40 there it's not. Along with his line of sight, there it is. So there's 40 degrees. What is the distance between Big Al's friend and the building? All right, we had this common sense check the other day, right? Distance between Big Al's friend and the building. Is that the hypotenuse or the other leg?
Other leg.
Distance between Big Al's friend, look at his friend, right here, friend, building. Friend, building. We're okay? We're solving for the other leg. All right, I need help with my problem I had earlier. Here's my right triangle. That 40 is located outside, so I cannot use it when I do opposite adjacent hypotenuse. Can anybody help me get that 40, use the 40 to get an angle inside the triangle somehow? Because there's two different approaches we could do here. How can I use the 40? Nick, one way. Well, they are horizontal. So they are parallel. Keep going. Why do you need them parallel? So you can say what? If that's 40, that's got to be 40 because they're alternate interior. Or the other way is, can I get the other angle? Dylan, go ahead.
It's a right angle.
Hey, okay, hold on. Hey, yep. Look, horizontal and vertical make a right angle. So if that's 40, you could use 50 here. Okay, so the adjacent angle is either complementary or you use the alternate interior. Your call. All right, I got the alternate interior first, so I'll use that one. But if you guys want to use the 50, go ahead. And the good news here, it doesn't matter if you use 40 or 50, you're still using the same ratio. So I don't care what you used here. 40 or 50, you should still be using the same ratio, which is what? 27. Which one of the three? Which one of the three ratios, sine, cosine, tangent, do I use here? Sine uses H for hypotenuse, and that's not labeled, right? 6 over here, I got opposite. Here I got adjacent. Tangent. Tan of 40. For me, this is the way I'm doing it because I picked 40 degrees versus 50. Opposite. Whoa! You better erase 16 if you put it in your ratio. That's not a side length. It's part of one. What am I putting in my ratio? 17.8, yeah. Got to add in Big Al's eye level. Over adjacent. Hey, if anybody used 50, you'd have X over 17.8 instead. All right, no big deal. All right, now we're on point, cross multiply. Us, everyone that used 40, we got to divide out at the end, right? I think if you use 50, you just get to cross multiply and you're done. We're at nearest 10th again. Yep. All right. When you got it, nearest 10th. Whoa, 2.
27.7.
I do not have 27.7. Let's go back to the calc. Why are we using cosine is my question. What's cosine? Cosine involves C, A. What's the H stand for?
Hypotenuse.
Okay. Is it labeled?
No.
Okay. What sides do I have? Opposite and adjacent. So what should I be using no matter what?
Toa.
Tangent. All right. Tangent. Should not be using cosine. I had no idea about the hypotenuse. 25.
20.2598107.
Are we all using like
I don't know.
calculators here? Where are we getting 20 from?
Oh. Okay. Yeah.
5. Third time a charm.
21.2.
There we go. Yeah. Good. Whew. All right. Oh. A little more than math in this class, huh? Standing on the gallery of a lighthouse. And if you didn't know, the gallery would be the deck at the top of a lighthouse. Anybody ever been in a lighthouse? Anybody ever been in at night? No?
Have you?
No, never been in one. Never been in a lighthouse. I just figured during the day, it's like, all right, at night with like the spotlight showing, and as that thing goes around, is that right? The light goes around on this, right? It looked pretty cool at night, but okay, never mind. We spot a ship, angle of depression of 20, right? Angle of depression of 20. So top of the lighthouse, looking down on the boat, not 20. Got to draw on the horizontal line of sight. Now you can put in the 20. All right, what else do we know here? The lighthouse is 28 meters tall, so 28 for the lighthouse, and 45 meters tall on the cliff. So 45 meters here for the cliff. Nice, nice. All right, can we just hold up 1 second here before we start calculations? What is the horizontal distance between the lighthouse and the ship? Everyone's think, oh, look, lighthouse, ship, right here, right here, right here. No, 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 no. Horizontal. If I wanted this, and you'll see this in the next problem, I'll write the word diagonal. But I want the horizontal distance from the ship to the cliff. So watch out here. All right, what do you want to do with that 20? Because I can't use it where it is right now. Your decision. 2, your decision. What do you want to use with that 20?
I'll make it a 70. And
All right, you got it. Good enough for me. Make that 70 degrees here. What ratio am I using here to find x? What ratio here do I need? Oh, 21. We're 3 for 3, aren't we? Tangent. Tangent for me of 70 equals x over, what are you putting for that other leg? Not 45, not 28. We're going to combine them and get 70. There you go. And you're on your way. Eight, rounded when you're ready. 12 when you're ready.
20.6.
Any questions? Last one coming up, huh? And it's completely blank. Here we go. All right, angle of elevation. So we know we're going to be looking up at something. Looks like from a control tower to the plane is 7 degrees. All right, let's roll. Don't go. Let's go. Control tower. It's my third one today. Just going with it. Just going with it. All right, just going with it.
Is that a division sign?
Brody, I will be around here in a second. Trust me, giving my comments out. So, yep, you guys better hurry up and put some detail on there because I'm coming around. And I don't want the cop-out rectangle for the, Here's the cop out, just doing that, or oh, here's my control tower. Cop out, cop out. All right, how about that 7 degrees now? Looking up, right? From here to the plane, and then my horizontal line of sight coming from the control tower. 7 degrees here. 7 degrees. The control tower, 200 feet high. Now notice how I changed the direction from the last problem. Oh, hold on, sorry. This word altitude, I know that's probably not a common term in here. In here it is, right? It forms a right angle. Altitude of a plane, the direct distance from the plane down to the ground. Okay, so it's literally right over your head. All right, 5,200 feet. Okay, that's what altitude of a plane is. It's direct distance from the plane to the ground. And notice how I changed up the directions here. What's the diagonal distance from control tower to plane? All right, see what you can do there. $7 degrees, not 70. Pop out. From a torch, that's good, Emma. Yep, from a torch. I'm gonna give you props for that. I'm gonna give you props there. I'll give it props when it's due. What do we got? Did a UFO land on top of something there? Just saying, bro. Just saying. Just saying.
Holy cow.
You should say control.
Let's see yours. Oh, it's got Mr. Curley.
I think Zach changed the problem from looking from a hammer to or actually, you know what? That looks kind of like a speed gun.
I did.
John is the definition of cop out.
Just right down.
Circles are good. I'm running.
I'm sorry to draw a control
From
tower.
one version
There's a
of the
person,
triangle
yeah.
to the other. Like it wasn't even like.
CT? Are you kidding me? CT? That's pretty sad that Andres is by far the best here.
I blew opposite here, but then that's actually really good.
Let me see it.
It's
Go up,
No, it's
Andre.
actually good. It's actually
got my plane right there.
It looks better than that. Of course.
I'm looking
Oh, yeah, look at that. It looks better.
All right. So we have opposite and we have hypotenuse. So hopefully we use the sine ratio here. Sine is 7 degrees. I know the hypotenuse is x. What are we plugging in for the opposite? 5,000, right? 5,200 minus the height of the control tower. Good. 5,000 over 1. Cross multiply. We end up with a pretty large number, which we should. Control tower is pretty far away from the airplane. And that is, where did I go? 41,000. 28 feet away. Yes, John. Sure. Other questions? All right, real quickly here, because for some reason, I don't know where it came from, but on your answer key tonight, so go to number 4 on tonight's homework for me. I don't know when we changed it, but you guys have a different degree measure and a different distance from the ground. So just, can you do me a favor on number 4? Where is it? I wrote it down. Where did I write it? No, I wrote it down. Where did I write the actual answer down? I just want to make sure you guys have the actual answer, not the answer that's posted there. See, this is what happens. I'm thinking about the brown and the beige crayon. And the white crayon, how it gets no love. Oh boy. Why do I want to say the answer is 32. But I have no idea.
We'll find out.
How about we all do it right now? How about that? And we all come to a consensus on what it is.
Yeah.
So try out number 4 right now, just so we can get it out of the way.
You have to draw. We have to draw them.
You do what you got to do.